So far in this section we saw a problem based on permutation. Now it's time to see some more examples based on combination. As we know that in permutation sequence matters, but in combination the sequence doesn't matter. For example, 1, 2, 3 and 1, 3, 2 in permutations are two different choices. However, in combination these two are the same. So the problem is we have given an array of integers and a number n. We have to find the ways in which we can pick n integers from the given array. For example, if we have given the array as 1, 2, 3, 4 and the number n as 3, so there are a total of 4 ways in which we can pick 3 items from the given array, and that is 1, 2, 3, 1, 2, 4, 1, 3, 4 and 2, 3, 4. To solve this problem, we start from the first element of the array and move towards the last element, and at each stage either we will pick the element on which we will be or we will not. Let's understand this with the help of the pictorial representation. So we will start with a blank partial solution, and first of all we are on the first element of the array, that is 1. According to our approach, either we will pick 1 or we will not. Now we move to second element, that is 2, but this will be different from the one that we saw in the last video in the aspect that we can pick only the numbers that appears after 1. That is, we cannot move back to pick the element. So again we can pick 2 in our partial solution or we will not, and then we move forward to the third element, that is 3. Again we will pick 3 or we will not pick 3. So for each node we will do this operation, and at last we will be at 4. So in this way we can see that we have our valid solutions that is marked in green, and the ones marked in red is not a valid solution. This is the code for this problem in Java. We have taken 3 parameters: the input array as input, a blank list of integers partial that represents our partial solution, and the index that will initially be 0. That means we will be at the first element of the input array. At each step we will increment the value of index by 1. At first we check if the length of the partial array is equal to n or not. If it is equal, that means we have selected n elements from the input array and hence we can have a valid solution, so we will print that solution and return. Again we will check if the value of the index is equal to the length of the input array. If this condition is true, that means we have arrived at the last element of the array and we cannot move further, so in this case we will return. Now if that is not the case, then we have two choices: either we will pick the element or we will not pick the element. So at first we add the element in our partial solution and then call the recursive function with the updated value of index, and again we will move the element and call the recursive function again. This is the Python version of the code.